Hello, everyone, and welcome to Advanced Product Demo Day, a special program from Vision Systems Design that highlights innovative new technologies and products in machine vision. I'm Dennis Scimeca, Associate Editor at Vision Systems Design, and I want to thank you for checking out the site. With me here today is Dustin Seetoo, Director of Product Marketing at Premio. Welcome, Dustin.
Hello, Dennis. Thank you for having me. I'm very excited to, be a part of your product demo day.
Today, we're going to discuss rugged edge computing. And with that, let's get into our first question. How would you define edge computing in its current form today?
Yeah, so edge computing as a whole is extremely broad. So I think in our thought leadership and our discussion, there's definitely no way that I'm going to address every single point. But the reason why Premio is participating in these product demos is to really showcase some of our rugged edge computing solutions and how they fit into the ecosystem of what edge computing is. So, very similarly, there is a hype about edge computing, but similarly, in simple forms of what edge computing is, it's basically moving traditionally all this processing power, compute storage into a more decentralized environment to where now you are sitting closer to where data is being generated, right? And that data is now being acted upon for real-time insights and real-time intelligence. So kind of in that sense, you can't really talk about edge computing without really kind of giving the history lesson and the recognition of traditional IoT, Internet of Things, and really what the cloud was. So right, in the last 10 plus years, everyone was really kind of speaking to the benefits of cloud computing, whether that be in the private or public cloud. And I think the cloud model has proven itself to really be a main stage and really be in combination and work with these edge computing models, right? So currently right now, you have these major cloud partners like AWS with their Amazon's AWS, and you have Microsoft's Azure. You can see that they're really trying to move closer and have these dashboards that can interact with a lot of the data from all these IoT sensors, right? So, I mean, by that alone, you can kind of recognize that these are major benefits from all this data that's acting, at the edge. So, I mean, some of the key benefits that come from that is now you have these devices that have the ability for remote manageability. You don't physically have to send someone there, right? You can provision devices sitting from a center or a center hub. In addition to that, these devices that come online now have the ability for data telemetry, where they can kind of communicate, ping whatever workload data that's the most important for that application in real time. So what I like to call and what Premio likes to call, the industry is kind of recognizing that there's this shift of the digitization of data, but really what I like to call it in that model is really a digitization of automation, right? Because once you have the ability for automation, once you have the ability for intelligence that provides additional layers of control that really helps drive better business decisions, helps you be more productive, efficient, right? So I think that's a very good kind of summary of, the state of where edge computing is and kind of where Premio positions itself in the ecosystem of edge computing as a whole. So yeah, in addition, I wanted to also mention, IoT investments today in the current model of edge computing, I think are starting to see its return on these investments because, in the last few years, all these IoT sensors have been coming online. But now as all this compute power, like I mentioned, of edge computing is moving closer to where the data is, that return on investments is really paying the dividends on all this incredible insights for intelligence. So, that's, in short, kind of where edge computing is currently today.
Okay. How is Premio empowering Internet of Things deployments to have more control and access to their data?
Yeah, so I think a good place to start with that question is really understanding the model of where the data needs to be. Once you understand where that model of the data needs to be, then you can start to strategically plan deployment scales based on compute resources in that scale. So just to kind of take a step back, if you kind of look at the overall ecosystem of how data it moves, right, at the core, which is traditionally the cloud has been proven to have the compute resources, it has the storage capacity to really kind of archive all this data. But really, Where I'm starting to see this convergence of all this new technology, right, is you're having a pretty solid symbiotic relationship between proven purpose-built hardware with incredible software machine learning algorithms that are really, being able to run these intelligent automation for control and automation. So really where Premio has really been a player in this position, right? We've been in business for 30 plus years. But in those 30 plus years, we've worked with a lot of major enterprise customers to kind of grow and scale a lot of their compute architecture. But the benefit of that is we've really defined a lot of that into our culture and our engineering principles that really help our customers succeed with their products. So whether that be in the compute architecture, right, whether that be in kind of the manufacturing of these and really taking these products to scale, really allows our customers to have access to mission critical data at the edge. So kind of to focus on what we're doing to really help our customers access that data. All right, so lots of these customers really don't have a really, I would say, long-term understanding on the benefits of what they can do with compute, because as Premio, we work with a lot of these leading semiconductor innovators, right? Whether that be from Intel, whether that be NVIDIA on the GPU side, right? So by taking a lot of those roadmaps and really building that into our x86 compute designs, customers have the ability to take something off the shelf and really deploy smarter applications for a lot of these IoT deployments today. So, I mean, just kind of touch on what edge computing is, right? All this real-time processing, all this new data, and all this new sensors are really moving into our products, which are rugged edge computers, and it delivers reliability where it matters most. And then I think kind of the last thing, kind of the cherry on top of how we help our customers succeed is to really combine a lot of the ruggedization that's needed at the rugged edge. Right, you can't just put a traditional desktop computer in a remote, decentralized, or just mobile environment because it would fail. Right, so by combining a lot of our design, our mechanical ruggedization, we're really moving all our compute and all this transformative technologies into a key distinguishable, what we call like machine learning and intelligence at the edge. Right, so taking the traditional compute, ruggedizing that compute, putting the performance layers on top, and really pushing for reliability for these mission critical applications is how we're helping our customers access their data.
Okay. I think it's fair to say that an essential part of what is pushing edge computing forward are the specific transformative technologies demanding closer to destination computing. Can you give us some insight as to what those key technologies are and how they're intersecting with Premio computing solutions and rugged edge computing?
Yeah, so I touched a little bit about it in the past question, but I'll really focus on a few key distinguishable transformative technologies that are really trending across the industry in the element of compute and why that's benefiting the rugged edge. So number one, really transformative technology is the compute architecture, and a lot of these new smaller form factors. Right, these smaller form factors are really becoming power efficient. You're having smaller nanometer silicon, but these smaller nanometer silicon have so much jam-packed cores put into the silicon for incredible advancements of processing. So I mean, you're starting to see smaller silicon, lower power, push a lot of these new workloads and allow for a lot more intelligence through machine learning. Though that's one key transformative technology that's really kind of helping shape edge computing. A second key transformative technology everyone has heard about, and it's really stemming upon connectivity, but more specifically the wireless connectivity, right? So with 5G edge connectivity on the horizon, even with Wi-Fi 6, what this is allowing is really allowing these sensors that are deployed to actually ping that data that they create in an ultra low latency environment. And then when you really have a low latency to pass data back and forth in the edge ecosystem, now you really have a model for real-time decision making and processing where it matters most for a lot of these smarter applications. And the last major transformative technology, and it's kind of more of a industry trend, or I would say kind of a major topic in this industry, is the intelligence or the machine intelligence being pulled from these cloud models, right? So kind of just to touch a little bit about the cloud again, right? The cloud is proven to run these training networks or these neural networks because it has the resources, it has the powers to train the machine over time, right? So, but once that machine learning algorithm has been determined, has been proven, why this is transformative is because now it can be moved into the edge level to where it's becoming more of an inference model. And what that inference model is really no longer needing to train the machine to know specifically the intelligence. It now has a little bit of cognition through all this sensory data that's coming in, running that intelligent algorithm to now make the decisions at the edge. So for example, a great way of looking at this, inferencing, a great example that most people will understand in terms of inference models is these autonomous vehicles or commercial trucks that are driverless, right? If a autonomous car was moving from point A to point B, in that scenario, there would be so many different sensory data coming in, right? But if that vehicle had to really truly rely on the cloud to react and manage the data, it would almost, number one, it would take too long, but it wouldn't be able to do it fast enough, and there would be major risk involved, right? So the autonomy of the vehicles is really an inference model to where in real time, in decision with cognitive sensory ability and situational awareness, these cars or vehicles now able to make a decision with machine intelligence.
Why does edge computing in rugged environments matter, other than what we may have said already? And what key pillars does Premio focus on to deliver an adaptable and efficient rugged edge solution?
Yeah, so great question. So being in computing for the past 30 years, and specifically in two key major markets of compute, whether that be on the embedded side, which has always been that low power efficient, small form factor, and then on the other flip side of it, you had your high performance data center cloud stuff. So when we mention key pillars, one of the major benefits that we can kind of pull into that is we have engineering resources, we have experience with pulling architectures from both these facets of design into what edge computing is, because like I mentioned, edge computing is not either or. I think it's really a combination of both and how it interacts. So one key pillar that we continuously build off of is the compute element of it, right? Now you have a low power efficient CPU that has incredible processing power that's able to do able to compute complex workloads that are necessary at the edge. Second, I mentioned as well, connectivity. Once you have faster connectivity, low latency, more bandwidth, right? Now you can start to pass these data through these pipes in a pretty quick manner, but do it in a way to where it's most beneficial from the business. Another element to that that we're starting to see as a pillar, and this is also to kind of touch on some of the both facets of both high performance and the embedded side, is storage capacity. So what we've learned from the high performance side of it, storage capacity has always been, number one, it needs to be accessible, but number two, there needs to be high performance. But on the embedded side of that space, storage traditionally was a little bit slower. It's been kind of stuck on the SATA protocol, right? So as Premio, with a product that is in the product demo day that we're showing, we were the first to market to introduce a hot swappable NVMe storage in our AI edge inference computer. Whereas in most of the other competitors on the market really are still stuck on either an onboard NVMe or just traditional SATA storage. Another big element to that is you can't really talk about data, passed between these networks without hardware security. So on the hardware level, on the system level, how we really enable that hardware security is, just through the standard, which is through the Trusted Platform Module, and that's being the TPM 2.0. And that really just helps with a lot of the data encryption and the protection needed at the edge level. And the last most important thing is, taking our engineering design, but really pushing it to a level of ruggedization for these new remote mobile decentralized type of environments. So how we do that is most of all our AI edge inference computers or rugged edge inference computers are passively cooled. Passively cooled is basically removing the fan out of the infrastructure and really pushing forward a a fanless design architecture. So by actually removing that fan, number one, you remove a major flaw in reliability of the compute, right? And once you remove that fan, you're able to really, push the reliability of the compute product exponentially. In addition to that, right, we also push the products when it's ruggedization, we test and prove for the environments that they're going to be placed into. So whether that's, wide temperature, negative 40 C all the way to 85 C on the high, wide voltage, shock and vibration, even ingress protection for a lot of these, pollutants, whether that be debris or water. So it kind of shows, our decades of electrical and mechanical thermal engineering experience is really helping focus on these key pillars in our product design.
Okay. Last question. How can we frame the importance of these key pillars down to specific business benefits? What are the driving business benefits that you see in the intersection between the edge and the cloud? And what are some of the most exciting examples of this?
Yeah, so that's a great question. And I think it always needs to stem down to the business results and what is the return on investment, because then it's just, cool technology and what it can do. And I think currently the reason why, edge computing continues to grow and has so much interest is that it truly is a business benefit. And it is a convergence finally with all this new technology culminating kind of into one. So just to kind of recap, once you have incredible compute power, once you have incredible storage, once you have low latency wireless connectivity, that is kind of the precursor to a lot of successful business applications, new business applications for either reducing the cost, being more operationally efficient, and just being more productive as a whole. But really, some really big business benefits that I kind of want to touch on as a whole is the element of intelligence everywhere, right? So once you have these models being trained in the cloud for cognitive intelligence and then moved into an inference model, and then that inference model can now interact with sensory data. Once you have this intelligence across all different ecosystems, all different platforms, this is truly going to help a lot of businesses make better business decisions. It might even be able to mitigate risks, for example, and really help them strategically plan and be more, cost oriented. Another major thing would be the ability for autonomy in the infrastructure. So, autonomy in a whole is really the ability to scale economically and operationally. So once you have a closed loop of autonomy, and there's no, I would say, factors that are going to affect the autonomy for that, is the proven case of what edge computing is. And that as a whole is going to really deliver the intelligence a lot of these business applications are looking for.
Okay. Dustin, thank you very much for taking the time to speak with us today. To the audience, if you would like to learn more, you can go to the Premio website. That's premioinc.com, PREMIOINC.com. Dustin, again, thank you very much. And thank you everyone for your time. And we hope that you enjoy the rest of Advanced Product Demo Days.
Yeah, thank you so much for setting this up, and looking forward to everyone else on the Product Demo Day.
Thanks. Bye.